Good morning and welcome to our webinar on how to reduce carbon in construction and meet your 2030 targets, introducing Wagners CFT's new environmental product declaration. I'm Kelly Stewart, Marketing Manager at Wagners CFT, and I'm here with Product Engineer Parminder Singh. Parminder has an extensive background in composite manufacturing, showcasing an exemplary track record in various stages of production and manufacturing within the areas of FRP and polymer resins. Parminder has a special interest in optimising manufacturing processes, ensuring quality standards and driving innovation in advanced materials. I'd also like to welcome Stephen Mitchell, who is the Director of Advocacy and Marketing from EPD Australasia. Stephen will be participating in the Q&A section of today's webinar following the presentation. But before we get started, just a few webinar protocols. We are recording today's event and we'll make the recording public via our YouTube channel. We're going to run through Parminder's presentation first and hold answering any questions until the end. However, you will see at the top of your screen there is a chat tab where you can submit a question anytime during the webinar. Those questions will be compiled for discussion at the end of Parminder's presentation. But first, let's set the scene. So what is embodied carbon? Embodied carbon is the emissions footprint which comes from harvesting, transporting and manufacturing building materials. Each stage in the process of getting building materials to a construction site causes greenhouse gas emissions. And this carbon footprint can be very significant. In fact, it's up to 39% of global carbon dioxide emissions. To understand embodied carbon, we need data, and this data comes from life cycle assessments, or LCAs, which look at the phases of each individual material's lifespan and add up all the carbon emissions that happen. Once we know the cradle-to-grave emissions of all the material in our building or structure, we can add up the sum total of those emissions and get a sense of the carbon footprint for making one particular building or structure. But for a long time, it's been really difficult to access LCAs. So that's made it really hard for someone to work out what the carbon footprint of a particular building might be. But now there's a report called an Environmental Product Declaration, or EPD, in which companies show the life cycle assessment of their products. These EPDs are conducted according to a set of international rules and usually carried out by a third party to verify the information. In an EPD, the embodied carbon is expressed in terms of the global warming potential, or GWP factor, for a given amount of a specific material. You can multiply the amount of material you are using by its GWP factor and figure out what the carbon emission for each material in your building will be. So why is this important to us? By 2060, the World Green Building Council expects the world's building stock to double, and as a consequence, we will see a corresponding doubling in the use of construction materials and associated emissions. To meet the challenge, Australia and its state and territory governments have set net timeframes and interim targets to reach zero net emissions. Nationally, the Australian government has committed in legislation for Australia to reduce carbon emissions to 43% below 2005 levels by 2030 and to zero net emissions by 2050. Like all states and territories, we're just going to use Queensland as an example. Queensland has set a range of emissions and renewable energy targets, including a 30% emissions reduction below 2005 levels by 2030. The indicative scope of where reductions in Queensland government infrastructure emissions will be applied include energy, transport, health, education, social housing, art, culture, sport and recreation, water and digital sectors. More specifically, we will see this in roads, bridges, busways, light rail, ports, airports, ferry connections, cycleways, shared paths, transport operational infrastructure, maritime infrastructure, dams and weirs, water and wastewater treatment plants, hospitals, detention centres, the list goes on. Now, at this stage, you might be thinking, yes, but this doesn't really have anything to do with me. I mean, they don't even include it in tender documents. Well, the current roadmap for the rollout of Queensland's emissions and renewable energy targets is set to build on successful existing actions, which include the Queensland Procurement Strategy 2023 commitment to reduce emissions. The strategic direction to reduce infrastructure emissions will include embedding emissions reductions in infrastructure decision-making, the reduction of embodied and operational infrastructure emissions, and the growth of green supply chain. One of the choices of how government plan on achieving these targets is to build clever and more efficiently by using low carbon materials with long design life expectancy. So when is this going to hit the ground? Target stakeholder engagement has just concluded in Queensland, with feedback on the discussion paper closing out in November just gone. According to that document, public release of the roadmap is earmarked for early 2024, with implementation planned for late 2024. So in summary, reductions in carbon emissions have been legislated at a federal level. All states and territories have committed targets to achieve. Queensland has committed to a 30% reduction in emissions below 2005 levels by 2030. And these key targets have been incorporated into Queensland's procurement strategy and will be key tender requirements by late 2024. So now we know the why, and without further ado, I'd like to introduce product engineer Parminder Singh, who is going to take us through Wagners CFT's new environmental product declaration, which is the only one of its kind for pultruded fibre reinforced polymer profiles in Australia, and only the second in the world. Please note, Parminder will be walking us through some worked examples and a comparison calculator. We'd like to flag that these workings are Wagners' internal documents, which we have developed as part of understanding and benchmarking our newly achieved EPD, and these calculations are currently under peer review. Parminder.
Thank you, Kelly, for the introduction. Good morning, everybody, and thanks for your time for this presentation. I will just quickly share my screen. Right, so before we start about EPDs, there are a lot of LCA assessments and a lot of standards that are being followed. But the current EPD follows this specific standard, and the benefit of having EPD is that especially in construction, whatever EPDs you select, they have gone through similar protocols and standards. So it's really fair game and easy for the clients who want to look for the emissions. They can compare the results. So what's the objective of this webinar? We will go through what EPD is and what it actually offers. We will also talk about some of the benefits of having an EPD, and also talk about how to read EPD because it's a long document and things can get more complex, and especially if you are reading it for the first time. Also, we will compare some of the EPDs of different materials, and we will walk through how to make a better choice. We also have some examples for you. So comparing EPDs, and we will look into CO2 emissions and some other factors that are also important. And at the end, we will talk about a calculator that Wagner has made for you. So it's easy not to just go through all the EPDs, but you can use the calculator in a really simple way, and that will give you the proper emission comparisons. So before we start understanding about the EPDs, I think it's good to look in the past and to see how it all came into existence. So during the Industrial Revolution around 1950s, 60s, people were a bit concerned about like a lot of resources were used, especially coal. Excuse me. So the coal was a main source of power, and it actually, as you know, it's not one of its good kind of fossil fuel to be used as an energy resource. So people have bit concerns about it, and the term life cycle assessment was actually raised in 1960s, but there were no specific standards at that time, and people started misusing LCAs to just demonstrate how better their product is because there was no standards at that time. So looking at this in late 1900s, first ISO standard, which is 14,000, was developed, and later, especially for EPDs, ISO 14025 was developed, and European norms 15804, which is specially for construction, was also designed. So that's how the LCA assessment came into existence. So before we uh, go into more details, what is an EPD? It is a called Environmental Product Declaration, as you know. It is a form of a life cycle assessment. Especially for construction, you have two types of standards that are followed. ISO 14025 that gives you more of a framework and sort of a format or what sort of content. It's like a basic information you would need to perform an EPD. For especially for construction, EN 15804 is used, and the last A2 is actually the version number. So this standard tells you more in detail about the processes that needs to be carried out, and it's more of a systematic approach designed just for construction materials. There might are different EPDs for different purposes. You may come across it for an EPD which is solely focused on, let's say, furniture or maybe automobile. That will have a different ISO or EN standards. It is a globally accepted document, and it is a third-party verified. So that makes it really uh, promising to look into EPDs and compare because it has gone through so many stages. Uh, so the EPD itself is globally accepted. It is an international body, but EPD, there are different partners throughout the world just to publish and look after the EPD publications. In Australia, you will have EPD Australasia. If you move to a different western side, you will have different EPD partners, EPD Argentina, or you will have Brazil, and so on. However, EPD are globally accepted, so one published in Australia can be used in America. There might be different changes you have to go through just to make sure that you are comparing uh, comparing it fairly. But overall, it's a really flexible document. So what is the concept of an EPD? Let's say we have a project manager who is at the initial stage of selecting the material, and he want to make sure that he has different emission targets. He want to have the project at a specific cost, and he's looking for something that can last longer, have a great environmental performance. So in that case, what should he do? It's really confused. He can't just go to the Google and just look for different studies. So EPD gives you flexibility to compare between different materials to have to select a proper material that will be good for you. So EPD offers comparison between different materials. In this case, we will take three materials: GFRP pultrusion, treated timber, and galvanized steel. Once you know that what materials you want to choose, EPD also offer comparison between different suppliers for the same material itself. In this case, for example, our project manager is happy to use GFRP pultrusion, then he can uh, get EPDs from different suppliers of pultrusion products, and he can select whatever suits his needs or whatever pultrusion supplier gives them the less emissions. As EPD LCA is a LCA assessment, basically it follows some sort of the same format. So LCA assessments have all the product stages, any manufacturing, construction, emissions associated to usage, end of life, and any sort of recovery that the material can go through. These stages in EPD world have their own acronyms. So it is denoted in alphabetical form. So they are called modules, so A1, A2, A3 for raw material supply, as you can see on the screen. Same in construction process stages, they have different acronyms too. And this will be useful when we will go through to see how we calculate and compare the emissions. Also, EPD have what sort of modules are declared. So the highlighted modules here are compulsory for an EPD to be published. If you the usage stage and construction stages are not that important, as it all depends on complexity of the material itself. So the EPD, if you open an EPD document, it's a really long document. It has so many details inside. And I have made it more systematic just to understand how the formatting is. It will have a front page where most of the details will be there, company name, etc. It will have a bit of a journal information about contact details, verified document, and what sort of standards are followed. It will also have declared units, what sort of quantities used to calculate the emissions. Can be in kgs, can be in meters or cubic meters. What sort of modules are considered, what sort of material content is there. And at the last, you will have some sort of table that will have some numbers inside. And that can get a bit overwhelming if you see at the first side. But trust me, it's really simple and straightforward. So remember the table we discussed? There are basically 4 types of tables in an EPD. They all have different, they showcase different emissions and environmental impacts. So the first table, for example, will tell us more about potential environmental impact. We will go through them later in this presentation. The second table tells more about resources used. The third table will be more about waste categories and what sort of waste is generated, can be hazardous, non-hazardous. And the last table will tell us more about additional environmental impacts. So the table 1, basically it's the most important table in my opinion. It tells us about global warming potential. It's related to carbon emissions. We have eutrophication potential, which is formation of algae inside the water bodies that can reduce the water content and affect the marine life. Then we have acidification potential related to acid rain. Abiotic depletion means what sort of elements are extracted from the ground. We have ozone depletion potential, effect on ozone layer, and we have water depletion potential as in more of a water use. The second table will tell us more about renewable energy, type of energy used to make that product, any non-renewable energies, and what sort of quantities of fresh water was used to make that product. The third table will tell us about sort of waste, can be hazardous, non-hazardous, any radioactive waste that is generated, any quantities of materials that are can be used, any quantity that can be recycled, or any material that can be recovered using incineration or any sort of recycling process. The fourth, last but not least, table will tell us about type of particulate matter, if there is any emitted during the production or the usage process, any ionizing radiations, and ecotoxicity for freshwater. We have human toxicity and soil quality. And as you can see, it's not just focused on the carbon emission, but the impact on the environment is so complex that EPD actually covers everything. And it all depends on your priorities of what sort of area you are looking for. Maybe in more of a dry areas where there's not enough water, your priorities are to have to use the product that have consumed less water. You can refer to EPDs. So how to comprehend the information? Uh, in my personal opinion, I usually look for the declared units. So what sort of quantities are used to calculate EPDs? It can be in kgs, tons, cubic meters, etc. And then straight you jump onto the tables itself that tells you about the emissions. So the table may look like this in most of the EPDs. So if you remember, we have discussed the product stages. They have different acronyms. So the top column here will tell us more about the stages of the product. So A1 to A3 means the product stage and the usage stage and any sort of end of life and disposal stage. So top row is the product stages. The columns here on the left side tell us more about impact categories. So GWTP means global warming potential. You have water depletion potential, acidification potential, and so on. These are sort of SI units that are used. And the good thing about EPDs is the table and the formatting remains the same. So if you open an EPD of a galvanized steel, it will have exact same format, but only the numbers will be different. If you're more concerned about a particular stage, you can focus on particular emissions at a particular stage, or if you want to calculate the overall emissions from manufacturing to end of life, it's just simple as to add up all these numbers from left to right, and then you will get total impact category of that particular product. The scientific uh, numbers are used here. So there's no, if you're looking at it, it's basically 1.64 plus 1. That means you just multiply it by 10. So E01 means into multiplied by 10. So just a scientific representations of numbers and nothing else. So that was all about an EPD table and how sort of a bit of a detail and how to look for the emissions. It can get more complex, but it's won't be possible for us to take every detail in this presentation. Now, in Wagner's perspective, service life of the material is really, really important, and that can have a big impact on emissions. Suppose we take 3 examples here. You have pultrusion, timber, and galvanized steel. They have different service life. If we compare between pultrusion and timber, pultrusion offers 100 years of design life, so the product made out of pultrusion will last for 100 years. The same product made from softwood timber could last around 5 to 15 years. We have just taken 10 years on an average. So suppose you end up using softwood treated pultrusion product as a utility pole. You have to replace it every 10 years because it can't last in more acidic or aggressive environments. And in that case, the pole itself will have 10 times emission just to compete and have a 100-year design life with the pultrusion product. That means it's all about multiplication and the cost that comes to maintain or replace that particular product. So service life would have a greater influence. Same goes with the galvanized steel. And we have some examples that we will show you later on. The other key aspect is the weight of the product. So if you are comparing EPDs of 2 different materials, at that instant per kg of suppose pultrusion, and if you're comparing per kg of treated timber, they may sound really similar, or maybe in some cases timber may have low emissions compared to pultrusion, but it all comes to the final product. And we take an example of utility pole here. So utility pole made out of GFRP pultrusion weighs around 1/3 of the treated timber itself. And as you know that the emissions are linked to per kg of the product declared in the EPD. So if you put on the numbers, you will see as the timber is really heavy, it will have higher emissions, and pultrusion will have lower emissions because it is a product that gives you high strength and is a lightweight material. So it's more about more practical approach of comparison, not just kg to kg or just on papers. So if we compare the same scenario with let's say we are making a bridge out of pultrusion and steel. And this is one of the projects we have done with our clients. And the designs are verified through third parties. So we take an example of a deck made out of pultrusion, and same with galvanized steel. As pultrusion is around weighs half than galvanized steel, the emissions will be half because it's a lightweight product and you end up using less material compared to galvanized steel. And also it comes to 50 years of design life. So steel may have twice the emissions just to compete with 100 years of design life of pultrusion products. At the end, as you remember, we talked about comparing different EPD also offers opportunity to compare between different suppliers for the same product. Here, if we look for Wagners pultrusion, it is around more than 60% of the traditional pultrusion. The emissions associated to pultrusion itself is 60%. There could be a lot of reasons. Could be type of materials that different suppliers or different manufacturer use. Could be the fiber volume fraction, and there is a bit of a complexity here. And it is not possible to know each and every detail because of the proprietary technologies people use in their manufacturing. But if you just compare the numbers using EPDs, you will end up having some advantages of the EPDs as in the same category if you compare different products. So just to sum everything up, it can be sometimes more challenging to have to go through all the EPDs and through all the numbers as things get more complex, and there is a chance of having an error while you are comparing the emissions. So what Wagners is sort of following this, and this is still under third-party review. We have put everything. We have grabbed different manufacturers EPDs that are third-party verified, and we have grabbed and put all the numbers in a form of an Excel sheet, and that this Excel sheet can be supplied to you for your advantage of if you want to see yourself or compare emissions. So simply this allows you to put it actually calculates the emission by weight. So you just have to get the numbers of the final product weight that you are intended to use from different materials. You just crunch some numbers. So you just have to put the final weight of the product here, and automatically it will populate all the cells, and you can compare between different materials. At the moment, it is offering comparison between 3 materials, that is pultrusion, steel, and timber. But hopefully we will refine it to add more materials inside. And this is really simple and easy to use. That's all. I'm happy to answer further questions. Thank you.
Thank you very much, Parminder, for your presentation. I'm just going to quickly show some slides and give Parminder a chance to have a little drink of water and prep for any questions that are coming in. If you do have some questions, if you can put them into that chat box now, and we'll just quickly go through these 2 slides, which will take just a second or so. We're about to go into the Q&A section of the webinar. I just wanted to share these 2 slides about Wagners Holdings. So Wagners Holdings is listed on the Australian Stock Exchange. It was established in Australia by the Wagner family in 1989. The business now boasts more than 1,000 employees in 7 countries with manufacturing facilities in Australia, the US and UK, and supplies construction materials and services globally. There's 3 main business units, including Wagners Construction Materials, which includes cement, fly ash, aggregates, precast concrete, reinforcing steel and bulk haulage services, Wagners Composite Fibre Technologies, which we've been discussing today, and Wagners Earth-Friendly Concrete. Wagners Holdings is still very much a family business, with Dennis Joe Neal and John Wagner actively involved in day-to-day operations. All right, so I'm just going to jump to a question that we were asked prior to the presentation today. And this one I might actually throw to Steve Mitchell, who's joined us today from EPD Australasia. Steve, can you tell us how often do EPDs get reviewed or replaced?
Well, hi Kelly, hi Parminder, and thank you very much for that presentation. I mean, I'm out of a job. You guys are very good at this. How often are they are valid for? They're valid for 5 years for construction products. So provided the process hasn't changed and your inputs haven't changed significantly to affect the results, they're valid for 5 years. In construction products generally, the processes don't change that quickly, so they use that validity period of 5 years is very common. People do update them earlier sometimes when they find that they've got efficiencies in their process. They voluntarily update it sooner and want to communicate a lower environmental impact results.
Excellent. Thanks so much for that, Steve. And we might jump to this first question that's come in from Ben Albany. He just wants to know, did we consider different wood species in your calculations, Parminder?
No, it is more focused on one type of wood as the only EPDs we can find that has gone through the same current standards for EPD. There are some different species, but they have followed older versions of the EN standards. So at the moment, we have just compared with one particular species that is a softwood timber. Yeah.
Parminder, how do people find, and Steve, this might be a good question for you as well. If people are looking for EPDs for products, where do they go to find them? Not sure if have we frozen there or. Parminder, can you hear me still?
Yes, I can. Yeah.
Yep, great. I think Steve might have just frozen there for a little minute. Parminder, can you just tell us where do you go to find an EPD?
Yeah, well, all the EPDs have to.
Oh, here we go. Steve's back.
Be an EPD program operator. Yeah. Can you hear me?
Yeah.
Yeah.
Sorry.
Can
you
hear me?
Hear you
That's
now.
good. Thank you. Yeah. So EPD Australasia's website, epd.australasia. Oh, sorry, epd-australasia.com. All EPDs have to be published with an EPD program operator. So we set up the framework for the standards that Parminder was talking about there, as well as the rules for their independent verification. So they all have to be publicly available. So we've got over 200 EPDs now published for literally thousands of products available through that website.
Steve, can I ask as well, I mean, is there different types of EPDs? And if there is, what's the most stringent type?
As Parminder was talking about there before, the overarching EPD standard is ISO 14025. So you will see EPDs for that just comply with that standard, ISO 14025. But the higher standard, EN 15004, that specifically applies to construction products, all the EPDs registered with our program must also comply with that more stringent standard. And that puts everyone on a level playing field so that they've got to report the same things. I really like Parminder's presentation there. Pre-EPDs and LCA, people were making all sorts of claims using LCA methodology. But one of the good things about compliance with EN 15804 and ISO 14025 is that they have to report on impacts that mightn't show their material in the best light. So they've got to report on a range of environmental impacts, not just embodied carbon. So it puts every building product supplier on a level playing field, if you like. So they're the relevant standards, and so all the EPDs registered with us must be independently verified as complying with those standards.
Mm. Parminder, I'm just going to jump to this question that Valentine Figueroa has asked. He just wants to know, in your calculations, I think you were saying that the EPD that you used for galvanised steel had a design life of 50 years, and he just wants to know which code notes that steel has 50 years of design life. Do you just want to explain that calculation?
Yes, so the service life or the design life, we just refer to the EPDs and what they actually say about the design life. We don't go out of the EPDs if we want to have different comparisons. So having 50 years to design life, we have just gone through the numbers that the specific EPD is saying that how many years they follow. It could be different for different manufacturers, and it all comes to what sort of thickness of the galvanized steel has for the galvanization process. So for that specific supplier, they just offer 50 years of design life. That's why we just have selected 50 years for now. Yeah.
Mm. Valentine, if that, I hope that answers your questions. If you do have some more questions, just pop them in the chat box and we're happy to discuss that a little bit further if you like, or take it offline and go into more detail with you. We've been just asked the question as well, Parminder, whether that emissions calculator that you shared will be shared with the people who attended today's webinar.
At this point, it's not third-party verified, but once it's third-party verified, we are happy to share it with you. So yeah, you can use it in your computers and just play around with it. Yeah.
We've got a really good question that's come in from Robbie Wesley, who is one of our business development managers in South Australia, Western Australia, Northern Territory. And he's just asking, in some situations where the results of carbon calculations may be beneficial to the case for specification of WCFT or Wagners Composite Fibre Technologies over traditional materials, is Wagners happy to assist in the process to help designers or customers make a case to the decision makers?
Yes, we can, absolutely. Yes, that's the whole point of having these sort of comparisons, just to assist our clients of what was the best suited design for them. And obviously we can work things out and work things out from the design perspective and offer the least emissions if they like.
I think the other thing just to share with everybody as well is that this has been an incredible journey that Wagners has been on, and the skills and knowledge that we've gained through that process, we're more than happy to share. And we're also happy to, introduce people that we've met through that process as well. Steve, do you just want to talk to perhaps, this is not easy. It is can be challenging for people to make their way through this gauntlet of EPDs. What sort of support and what sort of help is out there for people who have questions?
Yeah, it's a difficult process for the manufacturers of these products to go through because there's a lot of data to gather. But I'm confident by the fact that you have learnt a lot through the process, and that's one of the great strengths of the EPD process is people understand the hot spots in their supply chain and their manufacturing process, and that often results in people improving their manufacturing processes and supply chains and reducing their environmental impact. So that's an internal benefit of EPDs. And that's so decision makers and people specifying products, just by the mere fact of asking for an independently verified EPD, are facilitating that process. I also have a job of talking with companies about developing EPDs, and if customers are asking for them, that definitely helps underpin companies like Wagners' investment in this transparent and credible document and data. So I'm not sure if I've answered your question specifically, but construction projects, building projects that are seeking Green Star certification or are seeking Infrastructure Sustainability Council certification through the IS rating scheme. I note your requirement there, developing requirement there in Queensland for embodied carbon reductions. So these are all driving people asking for this information, and then what's happening now is a lot of sustainability professionals, you know, yourself, a lot of commercial projects, they use experts of all sorts, fire, you know, structural, you know, environmental, and this is just another profession there where people are using this information in sustainability assessments and to obtain green certification, and EPDs are highly valued for the credible data that they provide. So people can make quantifiably better purchasing decisions when it comes down to it and improve their environmental footprint of their projects.
Robbie's just asked another question there too, Parminder. Is the EPD all-encompassing? So it's not only calculating emissions, but also considering long-term environmental effects like leaching of toxins or micromatter into the environment. You know, is there something that, you know, focuses on that in the EPD as well?
Yes, I think, for example, let's say there is some material in the landfill, and so the EPD will calculate, or it will encompass the leaking of chemicals in soil or water bodies. So you will have those analysis in the EPD itself. But if we talk about, let's say, microplastics, that may not be there at this point, as it is, in my opinion, out of scope currently. But yes, it all depends on the situation and what sort of end of life procedures EPD suppliers have gone through, and that will actually influence the. But yes, it actually has all the chemical leaking out in the environment and all the environmental impacts. Yes.
I know that talking to Spiros, I know Spiros is on the webinar today as well, earlier in the week. He was asking some questions about end of life. Ryan Leeson, who is our General Manager, are you online today?
Yeah, absolutely. Yes, I am. Can you hear me there, Kelly?
Great. Yeah, Ryan, would you just like to perhaps talk to that end of life potential for fibre reinforced polymer now and in the future?
It's a rapidly developing space is probably the first part I'd say. You know, the products and the raw materials that we use are the same as the wind turbines that are made all over the world, and you know, have been designed with a 30 to 45 year design life typically, and most of those have gone in over the past 20 years. So as we move forward over the next 20 years, there's going to be an increasing number of wind turbine blades come towards their end of life, and that there's plenty of methods that can be used to recycle or reuse or break down and repurpose composite materials at this stage. They're just not overly commercially viable. So as we move forward and the supply of in-feed products increases rapidly, there will be the commerciality of those entities will also increase. There's a really good pilot program underway in the UK at the moment, and parts of Europe as well, where they're grinding and repurposing it into road bases and into concretes as a replacement for existing blast slag, furnace slag, and for fly ash, and also in road pavements as well. And we've been involved in a couple of studies in the US as well with materials from our plant in Texas. There's a factory there that's looking to grind it down to be able to reuse it in injection molding of plastics. It's a really good strength additive because of the glass content in it. So Lots of pilots underway, and we're proud to be a part of different pilots at the moment. Currently, it's really a repurpose game, and a lot of our material that's either reject or been returned to us at end of project gets reapplicationed into non-structural applications, fencing for farmers, culverts for private land applications. That's sort of the key points where our end of life material goes. But as we continue to move forward, and particularly in Australia at the moment with the development of our wind turbine industry, our post-processing and recycling is really going to develop maybe a bit later than parts of Europe that have been putting wind turbines up for a lot longer, but that will be a developing space, and luckily we'll be on the back end of the European and US pilots, and we look forward to being a part of that development.
Great, thanks so much for sharing that with us, Ryan. It looks like we've got to the end of any questions that anybody has. Steve, was there anything that you wanted to share with us before I round out the webinar today?
No, that's good. Thank you very much for the overview of your experience with using EPDs and your comparisons there. No, I just point people towards the website EPD Australasia. Please feel free to approach us with any questions if you're an end user of EPDs and you've got questions. I realise, as Parminder is saying, that they can be a pretty daunting document to look at in terms of numbers. But it's really good that you're just focusing on embodied carbon, and once you've got a handle around that, you can expand your understanding of other environmental impacts and how you might incorporate those in decision making. So that was a really good point that you made, Parminder. Yeah, but if you've got specific questions you want to ask, if you're an end user or want to develop an EPD, please come and see us or come and talk to us. Thanks.
Great, thanks so much. Very quickly, I just wanted to share this final screen and let you know what we've got coming up in the, just one moment please, coming up very shortly with the next webinar as well. All right, so I just wanted to say thanks for coming today. If you could take a little bit of time and complete the feedback form for the webinar, just use the QR code there, and very shortly I will put the link to the feedback form in the chat for today's webinar. Filling out these forms is so useful to us. It gives us a whole heap of information about how we can improve these webinars for you. So take the time and fill out that webinar, that would be great. And I wanted to flag that the next webinar we have coming up on the 27th of March is a case study on Huskisson Mangrove Boardwalk. And that's going to be presented by Thomas Schoen from MI Engineers and Cohen Jurgens from Jurgens Civil he's the Jurgens Civil Managing Director. So again, you can use that QR code and go straight to the sign up for that webinar. You can also find that on our website. So WagnersCFT.com.au. Just go to the webinar sign up tab at the top of the page and you can log on there. Plus you can also watch any webinars that have been hosted by Wagners in the last 12 months on that page as well. So I think that concludes our webinar today. I'm just going to put that feedback form in the chatbot there for anybody who doesn't have a QR code reader. And I think we will just head out on the little video that we came in on. So thanks so much for coming today. Appreciate it. See you next time.